Unit 8, Lesson 1, Constructing and Measuring Squares. If we have a square, the square is known by the sides. We know that in a square, the four sides are equal. So it's very easy to say this side equal to this side, equal to this side, equal to this side. That's why we call it square. Now, what is the length of the side? Let's say the side length, we're gonna share it with S. We're gonna count 1, 2, 3, 4. So I'm gonna say 4 units. And if you check the other side, you're gonna see it's 4 by 4. In this case, we can find the area because the area of the square is side times side, which means 4 times 4, which means 16 unit square. Someone will say this is very easy, we know it from before. Yes. Now the question is, if someone give me the area and saying that the area of the square is 25 units square, do I have to draw the whole square or I can find the side right away? We can find the side without drawing by saying the side equal the square root of the area. So the square root of 25 equal 5 units. And this is the way, if we have the area, we can find the side. And if we have the sides, and let's say the side is 6 units, we can find the area by squaring the side, which means 6 square, which means 36 unit square. So from this lesson we know that if I have the area, I can find the side lengths. If I have the side lengths, I can find the area. But this is not our lesson. Let's see how we can focus or how we can use this knowledge to create something new. Let's say we have a line, and this line is horizontal line. And someone asked me, what is the length of this line? I need the side. So I count 1, 2, 3, 4, 5, and I say, it's 5 units. After that, we'd say, okay, we're gonna use another line, but this time it's vertical. What is the length of the side? So again, I'm gonna count how many units do I have? 1, 2, 3, 4, 5, 6, 7. So I can say the length is 7 units, which is very easy in case of horizontal and vertical. But the problem is, if this line is not vertical or horizontal, it's diagonal. In this case, there is something different. So if I have a line with this way, from this point, let's say, I'm gonna change the color to black, and I'm gonna draw the line. Let's say from here to here. This line, as you can see, diagonal. To find the side length, it's impossible to count how many units, 1, 2, and 3, and we say this is 3. If it's horizontal and vertical, yes, there is 3 and 2 here, yes. But diagonal, we cannot do it with this way. So we have to find a strategy how we can find the length of this line without using the ruler. So the first step is to count how many horizontal unit and how many vertical unit this line is doing. So it's 3 unit horizontal and 2 units vertical. This 3 and 2 will help us to create a large square of 5 units. So my goal is to create a square, and this square, we're gonna draw it, let's say, in green. And we'll say, I will create a square, a large square in green, 5 by 5. This 5 came from 3 plus 2. This is the first thing. After that, I'm gonna create a square using this black line. But someone will tell me how you can use a square using this length and you don't know the length, it's easy. All we have to do is to use this strategy. I come with the black again and would say what? I'm gonna create distance by 2 by 3. So if I have 2 here, I come after 3 unit and I draw a small dot. After that I'm gonna say this is 2 and 3, 2 and 3. And now I'm gonna join only this dot by this black line to create a small black square. And for sure this is a square, but I don't know the length of the side. Why I'm doing that? Because my goal is to reach the side or the length of the side. This is my goal. I need to know the length of the side. So that's why I'm creating this square. Now the last step is to color in red, let's say, the small triangles, the 4 small triangles here. Why I'm coloring this triangle? Because these triangles are congruent. Someone will tell me why they are congruent. I will show you in a second. First of all, this triangle, they are a right triangle because there is a right angle. And the second thing, if you see, the height and the base is 2 by 3. Here 2, here 3, here 3, 2, 3, 2, 3, 2. That means they are congruent. They have the same area. So what the purpose of doing all of that? The purpose or the goal is to reach the length of the side. How can I reach the length of the side? If I go to the first explanation, I said if we know the area, we can get the side. So can I find the area of this black square? If we can, in this case, I can get the length of the side. So from the beginning, let's say we had AB. AB was the line that I don't know the length of it. And this is what I'm looking for. So how can I get AB from all of this? First of all, I'm gonna choose the green color. And I'm gonna use the green color to create or to find the area of the large square. The large square, it's in green, that's why I'm using the green. We know it's 3 and 2, that means 5 by 5. That means the area, it's 5 by 5. That means 25 unit square. I got the area of the large square or large green square. Now let's find in red the area of each triangle. So area of each triangle. We know the formula, it's half time base time height, which means half the base, it could be 2 or it could be 3. If the base 3, the height 2. If the base 2, the height 3. So no problem. So times 2 times 3. I simplify 2 with 2. That means equal to 3 unit square. And this is the area of one triangle. Let's see the area of the 4 triangle. So I'm gonna type here in red again, area of 4 triangles. If the triangles are congruent, that means 4 by the area of 1, which is 3, that means 12 unit square. Someone will ask me why you are doing that. All my goal is to get the area of the black square. So if I subtract the 4 triangles or the 4 area of the red triangles from the large square, which is the green square, I can get the area of the black. So I can change now the color, and I say in black the area of small square equal the area of the large green square, which is 25, minus the area of the 4 triangles in red, 12. The answer will be 13 units square. That means the area of the black square is 13 units square. Someone will tell me, why you are doing that? I'm doing that to get the length of the side. And from the beginning, we said if I have an area of a square, I can find the length of the side by finding the square root of this area. So if now I have the area already 13, that means I can find the length of AB. I can say AB equal square root of 13 units. Someone will tell me, I don't have calculator. You can leave the answer at square root of 13, no problem. But for your knowledge, square root of 13, we need to know approximately it's how much. If I'm asking myself, what is the smallest or the previous square root or the perfect square of 13? The perfect square is going to be, in this case, 9. The next perfect square after 13, it's 16. The perfect square of 9, this is coming from 3 by 3. And 16 is coming from 4 by 4. If 13 is in between, that means from 9 to 13, I need how many units? Approximately 4 to get the 13. And from 13 to 16, how many units I need? Approximately 3. So it's almost like here 4 and here 3. That means it's closer to the 16. That means it's we can say 3.5 or 3.6, approximately at that number. But I don't have to find this number. All I need to know is square root of 13. If I have a calculator, I can use a calculator and I say, what is the square root of 13? So let's say I'm gonna check the calculator. I have 13. Square root of 13 is 3.6, as we said here, 3.6. Someone now will ask me, wow, before I was thinking that I can count 1, 2, and 3 and say this is 3. No, as you can see, AB, it's not 3, it's more than 3. And actually the answer is 3.6 because it's square root of 13. So this is a strategy line. I hope you understood this lesson, and the next lesson is going to be 8.3, which is the third lesson of unit 8. Thank you.